So in this question we've got a triangle OAB, and from this triangle we've got a point C which comes in a straight line from point OA and meets at point C. So from this line OA it meets at point C, and then this point C crosses the midpoint of AB at point M and intersects OB at point N. So that's the design of the triangle. Now we're given that OC equals 2 times OA. So OC, that's this bit, is twice OA. So this and this are both the same length. And as I said, M is the midpoint. The straight line CM cuts OB at N. So CN cuts OB at N. So OB, that's the point N, and that's CN. Okay, right. So we're also given that the vector OA is equal to A and the vector OB is equal to B. So let's write these up here. So OA, so it goes in this direction, and that is A. Now remember, we know that OC equals 2OA, so this AC is also equal to A. And OB is equal to B. So OB, that's this one to this one, that's B. So that's all the way across there. Okay, so let's just draw that in there, just make a little mark. Now, we've got three parts of this question. The first one asks, find the vector CM in terms of AB. Now, CM is this vector here. Let's just write this up. We're looking for CM. So in this direction. Now, how can we calculate that? Well, CM, what we know is we've got CA and we've got AM. So what we could do is we could add those up. So CM, that's our vector there, that would equal CA plus AM. Okay. So CA is this vector here, and it's going the opposite way of the direction of the vector. So that is just minus A. Now AM, now this one, for A to M, we go from C to A and then A to M. Now that is the midpoint of this vector here of AB. So therefore what we've got is we've got B going in this direction. So it's plus 1/2 of B as it's the midpoint. And here, as it's going in the opposite direction from C, we know that this is going to be minus 1/2 of A, of the vector A. So now we can simplify that off. We've got minus A minus 1/2 A. So that equals minus 3/2 vector A plus 1/2 of vector B. Okay, so that's part A taken care of. Now let's have a look at part B. So part B says to show that ON equals this, 2 minus 3/2 lambda times the vector A plus B times lambda over 2. So it's half of that. So we need to show that. So ON. So how can we calculate the vector O to N? Well, we know what O to C is. That's going to be twice the vector A. So that equals the vector OC plus CM. We know what CM is, but we don't know the length of this. But we could call that some constant lambda. So plus lambda times the vector CM. Okay, right, let's work out what that is. So OC, what is OC? That's 2 times vector A. 2 times vector A. And then we add lambda times CM, which is this. So that's minus 3/2 vector A plus 1/2 of vector B. Okay, right. Now I want to get that into this kind of format. So we need to get the A vectors and the B vectors separate. We've got them inside this bracket here, so let's move them around a bit. So we've got 2 times vector A minus 3 lambda A over 2. That's that one there. And then we've got plus lambda 1/2 of B. So that's plus 1/2 lambda b. Okay, well we've got half lambda b here, and now we need to factor out an a, so let's do that. So that equals the vector a, so that would then give us a 2 minus 3 over 2 times lambda plus, then we've got lambda b over 2. And that's exactly what we wanted for this one here. Obviously the vector on this side or this side doesn't matter. So that's part B taken care of. So now let's have a look at part C. Okay, now for part C, we've got to prove that ON is in the ratio to with NB at the rate of 2 to 1. So ON, that's ON and NB. So what they're saying is that ON is twice as long as NB. So how are we going to show that? Well, that is the vector B, which we've got in terms of this part of the question here. But then we've got also the vector A going in this direction. Now what we could do is, if we could set the vector A to 0, because OB is just the vector B, what we want to do is set this to 0 and then solve for lambda. So if I do 2 minus 3 lambda over 2 equals 0, and then I can bring this to the other side, so 2 equals 3 lambda over 2. Now times both sides by 2, so now I'll get 4 equals 3 lambda, and now to solve for lambda I just now divide both sides by 3, so therefore lambda equals 4/3. Okay, so ON, if I just take the vector ON, and let's just write that bit in the middle inside here. Now the vector ON, that equals, got vector A times 2 minus 3 times 4/3 over 2 plus 4/3, and that's my vector B, and that's all over 2 as well. So let's simplify this off. Now let's work out what this is. 3 times 4/3. 3 4s are 12, divided by 3 is 4. 4 divided by 2 is 2. 2 minus 2 gives me 0. So this factor now cancels out. Now I've got 4/3 divided by 2, or 4/3 divided by 2 is just 2/3. So therefore I've got ON equals 2/3 of the vector B. So ON, this bit here, is 2/3. Well, if that's 2/3, then NB must be 1/3. So hence, I've now shown that ON to NB is 2 to 1 by this value here and this value here. Okay.